All right, folks, today we are going to talk about circuits. So please make sure that you have logged on to the student-paced Nearpod for circuits, and we will get started with notes. Quick announcements, bring in 2-liter bottles, please. Also, for this lecture, please have a Snaptricity kit at your seat for this Nearpod. We are going to be doing some hands-on stuff today, and you will need the Snaptricity kit with you in order to do that. Feel free to share with your elbow buddy. All right. First things first, I need you to go ahead and take Quick Quiz B.1. That should be posted on Schoology. Once you have Quick Quiz B.1 taken, I want you to go ahead and set up your notes. Our essential question for today is, how does a circuit work? Your guiding questions are, how do you diagram and build A, simple circuits, B, series circuits, C, parallel circuits, and what is the difference between an insulator and conductor? I'm not actually going to use this timer, but you should go ahead and pause the video, take your quick quiz, get your notes set up, and when you're done, continue this video. All right, our learning target for today is I can diagram and build series and parallel circuits. Today's lesson, we are going to learn about current electricity. By the end of the lesson, we will know how light switches work, what electricity is, and even how to create an alarm. So we're going to start out by watching a video and listening to a song. As always, I'm only dropping the most fire tracks in this class, and today is no different. This is a song about current electricity. As you listen to the song, be prepared to answer the following questions. What is electricity? How does a circuit work? And what are conductors and insulators? I'm going to go ahead and let you play this video on your own. So go ahead and pause the lecture video, go over to Nearpod, play this vocabulary video, and when you're done, come back to this lecture. All right. I want you to go ahead and take a quick 4-question quiz about electricity and check to see how you did. All right. So, first thing I would like you to do is go ahead and draw a closed or open circuit. If the circuit is closed, I want you to go ahead and color in the light bulb, and or if it is closed and we can see electricity flowing. So I'm going to go ahead and draw this, or I want you to go ahead and try drawing it yourself. So go ahead and pause the video and then go ahead and play it after that and see if your answer matches up with mine. All right, so the first thing I'm going to do here is draw an example of an open circuit. So for this, I'm going to draw a wire coming from the negative terminal of the battery and connecting to the light bulb. You will notice when I do that, I do not color in the light bulb because this is an open circuit. In order to get the light bulb to light up, it has to be a closed circuit. So I'm going to draw a wire going from the positive terminal of the battery down to the light bulb as well. And then I'm going to change my color, and I'm going to show that my light bulb lights up when I do that. You can go ahead and try this out with your Snaptricity set, and you can connect a wire from the positive node of the battery to the light bulb to the negative node, and you'll see this happen. All right, we are going to be making circuit diagrams today, so there's going to be a lot of drawing going on. So in your packet, you should be opened to the circuit vocabulary. If you flip through your packet, you should be able to find that. On the bottom of that sheet, you're going to see this little legend that shows you all of the different types of symbols that we are going to use. I'm going to do my best to draw circuit diagrams on here using these symbols. Please realize I'm doing this on a computer, so it is going to be real sketchy. I'm hilarious. So, but try to draw along as you go through this. So, electric circuit is a path in which electrical current flows from a source flows. A closed circuit means that current can flow, and an open circuit means that current cannot flow. We are going to be focusing on using mostly wires, light bulbs, and batteries today in our diagrams. So what I would like you to do first is take a moment and use the Snaptricity kit at your desk to make a closed circuit with a light. If it is closed, your light should light up. Go ahead and pause the video and do that. Once you get a light to light up, continue the video. All right. I want you to go ahead and draw a diagram of the circuit you just made in your notes using the proper symbols. Go ahead and pause the video, draw the diagram, and then open it back up, and we'll draw it together. All right, so your drawing should look something like this. There we go. All right, so I'm going to go ahead and start off by drawing my battery, which looks kind of like this. And then I'm going to draw a wire going around and connecting to my light bulb, which is going to kind of look like this in my drawing, and then connecting back up with wires to the other side of my battery. So this is what a drawing of a closed circuit should look like. If you build this, the light bulb should light up. So if you're having trouble getting this to light up, you can check with someone sitting near you and see how they got their light bulb to light up. All right. Next, I want you to build a circuit with two LEDs. LEDs means light emitting diodes, and those are just our light bulbs. And I want those two LEDs to both light up. Now, there are multiple ways to do this. I want you to pick the one that works best with you. Go ahead and pause the video and start building that circuit. All right. Now that you have your circuit built with your lights, I want you to do something, and I want you to remove one of the lights from your circuit. Just literally take it off of the Snaptricity kit, and I want you to look at the other light, and I want you to answer, what happens to the other light? Does that light stay lit, or does it go dark? Go ahead and submit your answer. All right. If you did this exercise and your other light went dark, that means that you built a series circuit, and it looks something like this. You might have more wires in there, it might be bigger, you might have less wires, that's fine, but it should basically look like this. And a series circuit is a circuit where the current can only follow one path. So in this case, the current can go from here around and back to the other terminal. There's only a single pathway. If one part stops working in a series circuit, then nothing works. If you don't already have this built, I want you to go ahead, pause the video, and build this series circuit. All right, before we go on to the parallel circuit, let's just go ahead and quick draw a series circuit right here. So somewhere in your notes, go ahead and draw this for series, and we have our battery right there. And then from our battery, we have our wire going, and we have our first light bulb right here. And then we go around, and we have our second light bulb right here. And then we go back to the battery. And that's our series circuit. So make sure you have something like that drawn in your notebook or your notes. All right, parallel circuit. Some of you may have built this for your circuit. And this is a current that this is a circuit where current can follow more than one path. If one part of a parallel circuit stops working, the other parts will continue to work. So if you removed either of these light bulbs from your circuit, the other light bulb would continue to work. So I want you to go ahead and build the parallel circuit shown here, and then I want you to draw it in your notes. All right, let's go ahead and see what that drawing would look like. So I have my battery right here. And then I have my wires coming out from the battery, and I go ahead and have my first light bulb right here. Whoa, I don't know what just happened there. That was weird. And then that comes around back to the battery. Now, I go ahead and draw a second path for the wires to go, in which they go right here. swoop around for the light bulb, and it connects back with the main path. So we see that the electricity or the current can follow two paths, one going to this first light bulb and back to the battery, the second going around to the second light bulb and back to the battery. All right. That's our parallel circuit. So, as we just said, you already did this. Draw the parallel circuit using the proper symbols in your notes. Finally, we're going to wrap this up by talking about conductors versus insulators. Now, a conductor is a material through which electricity can flow. So, the wires are an example of a conductor, which is why our light bulbs light up. In a conductor, electrons are available to move. There is low resistance and so the examples of conductors would be metals and salt water. There is such thing as a superconductor, and this is when some conductors are really, really, really cold. They offer no resistance to the flow of electricity. There's also the opposite of a conductor, which is an insulator. This is a material which electricity cannot flow through. The electrons in an insulator are bound up. It has high resistance to electricity. Examples would be cardboard, glass, silk, wood, distilled water. So if you have purely distilled water, it will not conduct electricity, and plastic. We also have things called semiconductors, and this is a material that in some cases will conduct electricity, but not in other cases. All right, we got a 6-question quiz here, so I want you to go ahead and take the quiz to see what types of questions I'm going to ask on the quick quiz tomorrow. Pause the video, take the quiz, and then I'm going to go through each of the questions real quick. All right, would the light bulb in the picture turn on? Why or why not? It would not turn on because the circuit is open. Limes are a blank, which means that they can carry current. That would mean that they are a conductor. A circuit needs to be closed for electricity to flow. It does need to be a complete loop, otherwise the electricity cannot flow. Your pencil eraser is an insulator. This means that electricity cannot flow through it. With the light bulb in the picture turn on, you can see that we have our battery hooked up and it goes around in a loop, which means that yes, it would because the circuit is closed. And finally, Marvin tested a material in his lab. He put it between a wire and a battery in a closed circuit with a light bulb. The object was a conductor, so he likely observed that the light bulb turned on. And if you answer those questions, then you should get 100% correct. If you have any questions, go ahead and submit them here, and I will make sure to answer them the next time we all get together. I want you to go ahead and self-assess your understanding of circuits between 1 and 5 and submit it. And finally, I want you to decide what you're going to do with the rest of your time in class. If you are a 1 or a 2, I want you to read pages 609 and 610 in the textbook, and that should help clarify circuits. If you are a 3 to a 5, I want you to work on the Snaptricity packet and try to create diagrams and builds that demonstrate today's concept.